What's happening, dogs? Mr. Allen here with some sequence action. We want to write an explicit and recursive formula for each one of these sequences that we have here. So is it geometric? Is it arithmetic? I don't know. We about to find out. For part A here, I have, oh my God, fractions. Whatever. All right, 1/7, comma, 2/7, comma, 4/7, comma, 8/7. All right, so fractions get kind of scary. But what did we notice about these fractions? All the denominators are the same. So if I just focus on what in the heck is changing in my numerator, perhaps I can make this a lot easier. How would I get from 1 to 2, 2 to 4, 4 to 8, so on and so forth? It is doubling each time. So we essentially have a geometric sequence here, right, where my numerator is the thing that's geometric divided by just this number 7 the entire way. All right, so let's check it out. Let's see if we can write this thing. A, that is not an A. That's more like an A. Let's actually also say that it's geometric. All right, now let's say A sub n is equal to my first term, which is 1/7, right? Actually, let's do this. 1 times, I'm doubling each time, right? So that'd be 2 to the n minus 1 all over 7. Would that work? Let's see here. All right, because I'm going out on a limb. If I plug in 1 here, right? If I plug in 1 for my first term, let's see if I get 1/7. I'd have 2 to the 0, which is 1, times 1, which is 1. So I got 1/7. If I plug in 2 for my second term, right? This is term 1, 2, 3, 4. It can help to write those numbers in some of these trickier scenarios. If I plug 2 in, I get 2 to the first, which is 2. Times 1 is 2. Over 7 is 2/7. 2/7. If I plug in 3, I get 2 to the 3 minus 1, so 2 squared is 4. Times 1 is 4. Over 7 is 4/7. Let's see it happens one more time, baby. One more time. If I plug in 4, I get 2 cubed, which is 8. 8 times 1 is 8. Over 7, 8/7. Dope. Dope. We're good to go, man. I like it. I like it. You could have also written it as, let's see here. We could even just say A sub n equals, you could do 1/7 times 2 to the n minus 1. That works too. I mean, technically we are just doubling it each time. I think honestly that looks a little bit better, but this is kind of like how my brain was thinking about it, like deal with the numerator as its own geometric sequence and then just divide everything by 7. We'll see. Okay. I think either one of those is cool, but if it's multiple choice, it's probably going to be written like this guy right here. All right, part B here. Ooh, decimals. Man, fractions and decimals in the same video. Mr. Allen, you crazy. I am crazy. All right. 6.1, 3.1, 0.1. Then there's a 9er. What in the heck? Well, hold up. If I subtract 3, I get 3.1. If I subtract 3 again, I get 0.0. If I subtract 3 again, I do actually get negative 2.9. So don't freak out about that little switcheroo of the decimals, if you will, because as we are going down, it does that. All right? So we're dealing with arithmetic, right? Arithmetic, as it has a common difference, is going down by the same thing each time instead of being multiplied by the same thing each time. And I'm going to have A sub n. I forgot my recursive up there. We'll come back to that. A sub n, right? And that's going to be equal to, and I got my first term is 6.1, and then my common difference is negative 3. So I'm going to do this, minus 3 times n minus 1. And if we want to clean that up, we get 6.1 minus 3n plus 3. So we'll have 9.1. Actually, I'd like to rather do, hold up, let's see if we can erase that nicely. There we go. I like to have it negative 3n plus 9.1. Okay, so there's my explicit, right? And then let's get our recursive, then we'll come back to that one that I neglected to do the recursive. So first term, so recursive here, recursive. I need my first term, a sub 1 is equal to 6.1. Got to have that because recursive is based off of the previous term. And then my recursive, the formula aspect of it is my previous term, which I notate as a sub n minus 1. And then I add in my common difference. In this case, it's negative 3, so we're just going to subtract 3. That's it for recursive. This is my explicit. Beautiful. Back up to the top here for my recursive formula. I apologize for skipping over that. All right. Here's what we got. So for recursive, I'm going to have my a sub 1, which is my 1/7. And then my a sub n is my previous term is always being multiplied by 2. So I'll take the a sub n minus 1 times 2. There we go. Recursive seems scary at first. I remember first seeing that. I'm like, what is this? And it's honestly not too bad. But all that stuff takes some practice, you know? All right, guys, so there we go. I apologize again for forgetting the recursive formula on that first one, but it made for a fun little end of the video, right? We got to go back in time. Always fun to look back, you know, in the past there and reflect and whatever. All right, I'm done. See you later.